Alright, so we're going to review for your final exam, yay, class test of this year. First of all, before we start, we're going to need to graph these different functions, but let's remember what the pictures even look like. It might have been a while. For example, what is y equals x squared going to look like? A parabola, excellent. Okay, and then how about maybe y equals the absolute value of x? What does it look like? A v, and y equals the square root of x. That's what kind of graph? The hill, right? Looks kind of like a hill. And then maybe y equals x cubed. So if you remember that one, that's the one that goes like this. Those are some parent function graphs that we've studied this year. Okay. Now then the question says graph and say the domain and range. So for here, we're going to graph this. And if you'll remember, when it's inside the parentheses, it moves you left and right, when you mess with the x-axis, and you do the opposite. So we're going to go left 2 and down 1. And what's the shape of the graph? You'll notice there's a square here, so the shape is a parabola. So go left 2, down 1, and then just sketch a parabola. Then it asks us to find the domain and the range. What's the domain of a problem like this? A domain of a hill. Yeah, all real numbers. In other words, all the x values. Because this is going to, the arrow is going to keep going this way, which means the x-axis has to keep going. How about the range? What's the range of this? Range of the y-axis. Right, greater than -1, or from -1 to infinity. So we'll say y is greater than or equal to -1, or some kids like to write it like this. Either way, it's the same. Okay, I'm going to give you a second to do B and C. All right, this is a V graph. So we're going to go right 3, and this means up 4. And sketch a V. For my domain, again, would be all real numbers. And my range, if you look at the range, it starts at 4 and goes up. So y is greater than or equal to 4. The next problem is a hill graph. And I think of it as it looks kind of like the shape of the square root. With x does the opposite, so we're going to go right 4. And this means we're going to go up 1. So we're going to start at this spot here and just sketch a hill graph. It's fine. Domain and range of this one might be a little harder, but the domain of this would be x is greater than or equal to 4. And the range, does it have the range? What's it going to be? Oh, where does it start on the y-axis? Yeah, 1. Okay. Number 2. These are just state the domain and range. I'm going to do one of these with you, and you can do the rest. But here's this problem. What's the domain of a problem that looks like that? Yes. You'll notice you're going to have to continue the x-axis so the graph can keep going. So if you have to keep the x-axis going, then all the numbers for the x's. So domain is all real. And then for the range, what's the highest and lowest point?
This is 2 and -1.
Okay, and remember when you write domain and range, you start with the smallest. So we're going to start with the smallest y value, which would be -1, is less than or equal to y, which is less than or equal to 2. Okay, I'm going to give you 1 minute to do B and C. Okay, I'm going to do B with you. If you look at the picture then, the domain is all real numbers again. And the range, okay, it's kind of tricky because of the arrows. So I'll notice that. So the range is from 0 and greater. So y is greater than or equal to 0, or you can write it like this. From 0 to infinity. Okay, let's move to number 3. Given the following function, and the point -1 to be located on the graph, state where the point would be located after the following transformations. All right, think back to when we transformed sine and cosine. That's the best way for me to explain this to you. Right? When we transferred sine and cosine, and we multiplied 2 by the whole function, okay, that affected the y values, right? It stretched it, didn't it, up and down? Okay, so if I'm stretching something up and down, if I'm pulling it, it affects y. So write yourself a good note on here, because remember, you can use these to write little notes on your note card to help you, okay? So this means you should multiply the y by 2. Multiply the y by 2. So if my point right now is negative 1, 3, I'm going to multiply this y value by 2, so my new point is negative 1, 6. Okay? Take good notes so that you can transfer them to your note card. Let's go to the next one. Here, I've got, remember when there was a 2 messing with x? Remember when you did sine and cosine and you messed with the x? Did a whole number shrink it or stretch it on the x-axis? A whole number did what? Compress it or stretch it, a whole number? Yes, it actually compressed. Okay? And the reason, or the way that you can look at that is, this means you're going to mess with x. So you're going to multiply the x value by, not 2, because 2 is going to double it. That's not going to shrink it. It's actually by the flip of it, remember? 1/2. That's why you're taking good notes. Multiply the y by 1/2. I'm sorry, I said y, x. Multiply the x by 1/2. So my original point was negative 1, 3. And remember, if you have a 2, it messes with the x. We're going to multiply the x by 1/2. Well, half times negative 1 is just negative 1/2. And the 3 stays the same. So let's move to C. All right, what do you think is going to happen here? If you've got a point, negative 1, 3, this part right here is going to move it to the what?
Right.
Yeah, so we need to add 1 to the x. And what is you going to do with the 1/2? When it's outside the function, what did we do earlier on A? We multiply the what value? The y. So multiply the y by negative 1/2. Multiply the y by negative 1/2. So let's do what we said. Add 1 to the x value. So negative 1 plus 1 is 0. And then multiply the y value by negative 1/2. So 3 times negative 1/2 is negative 3/2. Let's go to the next one. This time we have a point labeled 1, 5. What do you think I'm going to multiply the x by on this one? Come on, remember your trick. Not 2, you're close though. Negative 2. So I'm touching x, so I'm messing with x. So multiply x by negative 2. So I had 1, 5. Multiply that by negative 2. So now I've got negative 2, 5. Okay, the next one, E. What's this going to do, guys? Moves it what? A minus 2? Right, we're going to go down to, what messes with down? The x or the y? The y. So what do you think I'm going to do? I'm going to subtract what? 2 from y. And how about this? Multiply y by what? So if I subtract 2 from the y, I was at 1, 5. Now I'll be at 1, 3. If I multiply the y by 2, I'm going to be at what? 1, 6. So we're going to skip that just because of time. There's the next one. Remember these? Given a function x minus 2 and g is x squared minus 4, find. And we're going to do a and d right now. Find g of negative 3. What does that mean? G of negative 3. It's kind of like an input box. What am I going to input, guys? Negative 3. So g, actually right now, g of negative 3, the original problem is x squared minus 4. So everywhere we see an x, we're going to replace it with a negative 3. So now our problem is negative 3 squared minus 4. What is negative 3 squared? 9. So 9 minus 4 is 5. So g of negative 3 equals 5. Right, now, I want to show you something. D, and F are the same. I'm sorry, I said G. C and D. These two are the same, just written different. Okay? This means take G and plug it into F, doesn't it? And so does this, G of F of X. It means take F of X and plug it into G. Do y'all remember doing those? So I'm going to do D, and then you can do C. So take F of X and plug it into G. It's better if you have a pencil. We're doing D together. Look up here. We're going to do this one. So we're going to take F, right? Take F, and what am I going to plug it in for? G, right? So we're going to take F and plug it everywhere I see an X, which is just right here. So I'm going to take this and plug it in just right here. So I want an x minus 2 squared minus 4. How do you do an x minus 2 squared? Does that mean x minus 4 or x plus 4? Nope. It means x minus 2 times x minus 2 minus 4. To FOIL it. So I have x squared minus 2x plus 4 minus 4. I FOILed it. Now, combine my terms. Y'all see what I did? I just FOILed this. These cancel, so, and these you can put together. So the answer is x squared minus 4x. You try C. Right here, you try this one. You're going to take G and plug it into F, so I'll work that one for you. You're going to go the other way. So if you're using a pencil, I would erase this. And now I'm going to go the opposite direction. I'm going to take this whole thing and plug it into here. It's actually easier. So instead of X, remember X gets kicked out of the game. That's how we talked about it last time. And in its place, we're going to put this player in, and it seems x squared minus 4. So we're going to have x squared minus 4 because x gets kicked out. But negative 2 is still in the game. And then we combine like terms, so you get x squared minus 6. Now I'm just going to talk about it, but I'm not going to work it. On F, what does that little asterisk mean, actually?
Times.
It means times. It wants me to times these. X minus 2 times x squared minus 4. Remember that? And then FOIL it. Alright, let's go to number 5. Which of the following are actually functions? Remember, a function has to pass a vertical line test. A vertical line test. Can I draw a vertical line through A and it only touch one point? Yes, so this is a yes. What about B? If I draw a vertical line right here, it touches it twice, so is it a function? No. And then here, you kind of just have to check. Right here, here's the problem. If I draw a line right here, it touches those 2 points. So there's a no. Okay, now we're going to have to do some remembering. Like I said already, I don't want to sound like a broken record, but write really good notes on here. Because you don't actually have to memorize this, because what can you do to it? Put it on a note card, right? Okay, you have to have it written down so you can remember, but you don't have to memorize it. State whether or not the given function is odd, even, or neither, and if it's symmetric to the origin, y-axis, or neither. Okay, we're going to take notes right down the margin right here. We're going to need to write some things down to help you remember. Remember, if we call something even, because it's been a while, if something is considered even, it's symmetrical with the y-axis. Symmetrical with the y-axis. Right, and the way we proved it was, for example, x squared. So if I tell you f of x equals x squared, okay, watch. And remember what we would do is then we would try to plug in negative x and see what happened. Remember that? So then I would say, okay, well, what would happen if I took negative x and square it? What answer would I get? X squared, don't I? So maybe if you have a highlighter or a pen, okay, we'll say, all right, this is the even, and when I plugged in x versus negative x, what happened to my two answers? Did they match? Yeah. Okay, so when you plug in negative x and you to the problem and you get the same thing, if they match, they're considered even. Then we studied odd. And odd is symmetrical with the y-axis. I'm sorry, the x-axis is the wrong thing. Odd is symmetrical with the x-axis. So x squared, if you think about the graph, okay, x squared looks like this, and yes, x is symmetrical with the y-axis, right? Now I'm going to talk about x cubed. X cubed. X cubed is actually symmetrical about the origin. If you go back and look at the graph of x cubed, this is x cubed, right? Here's the graph. For example, a point here matches a point here. It's symmetrical about the origin. Remember? And that's what makes a function, where are we? Odd. So if I plug in negative x, look what happens. What does a negative x cubed give me? Negative x, right? Negative x times negative x gives you negative x. So it doesn't give me the same. What does it actually give me? Yeah, the opposite. That's what you meant. It gives me the opposite. Remember we remembered it? Odd is opposite. O and O. Okay, the last one is neither. Symmetrical to neither. Right, if you have f of x, you get x minus 1. Here's an example. And if I plug in negative x, do y'all remember what happens? One is opposite and one is not. Do you remember? They all have to be opposite to be odd. They all have to be the same to be even. Look, if I plug in negative x for x, I'm going to get this. And what happens when you compare them? One's opposite and one's the same, right? See, these are opposite and these are the same sign. Okay? So let's go and check. Ready? Let's look at A. State whether the given is odd, even, or neither, and if it's symmetrical to the origin, y-axis, or neither. So what you do is to check to see if it's symmetrical, what you plug into the function. You plug in a negative what? Negative x. Excellent. So I'm going to take negative x and I'm going to plug it in. Negative 2 times negative x squared. And then you simplify it and compare. So if I simplify this, a negative x squared is just what? What's negative x times negative x? X. So So you get negative x squared.
Negative 2x.
Yeah, I forgot the 2. Thank you. Now compare the two. This is my original and this is my new. Are they the same? So same means what?
Even.
Yeah, so this is even. And what's it symmetrical to? Symmetrical to the y-axis. If it's even, it's symmetrical to the y-axis. Even symmetrical to the y-axis.
Okay, gotcha.
You try B. Alright, just really quickly, I'm going to plug in, instead of x, I'm going to plug in negative x. So negative was already there. Now negative x cubed plus 5 times negative x. Then I'm going to clean it up. Okay, what does a negative x cubed, does that stay negative or turn to positive? Just this part. And this part is negative, right? But there's a negative in front, so what's it going to do? Turn to positive. And this makes negative 5x. Now let's compare. Opposite, look at your original. You're comparing it to the original. Opposite and opposite. When they're both opposite, what does that mean? Right, you're comparing this to the original. These are opposite, these are opposite. So therefore it's considered odd. Good, which means you're symmetrical to the x-axis. Thank you. Alright, let's move on. State if the function is symmetric with respect to the origin, y, or neither. Look at the picture. What is that picture symmetrical to? X, y, neither, origin. What is it symmetrical to?
Origin.
Yeah, it's a hop over the origin. Watch, this is the way I think about it. I look at this point here, and this point here, and I'm hopping over the origin. You could look at this one and this one, you're hopping over the origin. So this is considered, it's symmetrical about the origin. And we'll call it an, that's all it asks. Alright, the next part, number 8. You can use a calculator, yay. Alright, so grab your calculators really quick. If you don't have one, go get it really quick. Alright, so you got your calculators, good. And let's try it out. Express each angle in degrees, minutes, and seconds. Okay? Right now you can look, it's just in degrees. Because down here, there's degrees, minutes, and seconds down here at 10. You see the difference? Okay? This only has degrees, this has degrees, minutes, and seconds. So the way we did this is you go to 45.16, type it in, and write yourself a little note. Second app, DMS. You want to write that. So you go to second apps. That's the purple button. If you don't see it, look guys, here's the apps button. It's purple beside the map. And then go down to DMS. 4. Hit enter. Degrees, minutes, and seconds. Hit enter one more time, and there's the answer. It's that easy. You just have to remember it. So 45 degrees, 9 minutes, and 36 seconds. Go to the next one. Type number 9 in. 13.15. And where do we go? Second apps. Don't ask me on the final. You'll have to remember all on your own. So write it down on here. Go down to DMS, hit enter, and enter one more time. So 13 degrees, 9 minutes, and 0 seconds. Okay, let's move to number 10. Number 10 is the opposite. Expressing an angle because it's already in degrees, minutes, and seconds. You go the other direction. Okay, here's how to do it. Type in 15, go to second apps, and there's your degree symbol. Hit enter. 37, go back to second apps, and number 2 is your minutes. And here's the hard part, 12. Do you remember where the seconds are? Remember, for some reason they aren't there. Yeah, good job. To get to the seconds, you might write yourself a little note. This is alpha plus. They're right here, those little 2 green things above the plus symbol. So you go to alpha plus. and then hit enter, and you get 15.62 degrees. I'll walk you really quickly through the next one. 2. So make sure you get it right. And remember, it's second plus for the last one. Not second plus, alpha plus. So it's 2.25. You'll reach your degree mark. Alright, so that's 10 and 11. Go to the next one. Maybe we'll remember this a little better. Name 2 angles, one positive, one negative, that are coterminal. How do you make a coterminal angle? What do we have to add and subtract? Do you remember?
360.
Yay! So we know this one then. 360. So you take the 120 and you add 360, giving you 480 degrees. And you take the 120 and you subtract 360. Okay? Giving me negative 240. Now go to 15. We have time to go to 15 now. Skip over to 15. 2 angles, one positive and one negative coterminal angle. No, a different one. The one said coterminal. So negative 20 plus 360 and negative 20 minus 360, which is 340 and negative 380. Yeah. Find the reference angle for the following. Okay, now here's my hint for reference. Draw an angle that's 400 degrees. Where's it at? If you start here, you're going to have to loop all the way around. That's 360, right? This is 360. And 90 more is 450. Y'all remember that? Because I'm at 400. I've got to make a whole loop and go a little bit more. So I land here. My reference angle is always connecting to which axis? Very good, the x-axis. So what is it? Y'all remember? If I stop, the closest reference I have is 360, and this is stopping at 400. What's the difference right there between the two? 40 degrees. Okay, we're going to stop here for today.